So, good morning, students. Today I'm going to explain about the quantization. Okay, this topic it should be comes under the pulse code modulation. Okay, in last class or last video, I discussed the sampling and different types of or levels of sampling. Okay, now I'm going to talk about the quantization. Okay, here the quantization it is nothing but okay the result of our sampling, okay, like which we have divided that particular signal, okay, that we call it as a sampling. That results of that sampling, okay, it is going to, yeah, it is going to vary the different types of amplitude values, okay. Along with that, okay, it is going to consider the height of that particular amplitude, okay, amplitude, okay, that amplitude height, okay, it should be a minimum or maximum, okay. These two limits it is going to checking in the quantization method. I am going to repeat once again, okay. The sampling results in a series of our pulses, okay. It is going to vary at the amplitude values, okay. That amplitude values it is going to take in the um, ranges between minimum amplitude height as well as the maximum amplitude height, okay. These two values are the infinite, okay, infinite values between the limits, okay. This method we call it as a quantization method. Then the height here we call it as a delta, okay. So finally we got the formula, that is delta is equal to maximum minus minimum divided by L. Yes, L, whereas the L here, it is the resulting value, or it is the value of that particular amplitude, okay. That value here we call it as a zones, okay. See that what, like that is what here L is indicates the zones, okay. That zone it may be a minimum or maximum values. Then what is the quantization levels? Here the quantization level, okay, it is very important thing, this level it is going to checking, or it is going to assign the values, okay, in the midpoint, okay. That is very important in the quantization level. That midpoint, okay, it is going like it is going to taken the ranges from 0 to n minus 1. That okay, that n minus 1 here we consider as a L minus 1 values, okay. It is nothing but our resulting of our L values, or that the like that should be our zone values, means maximum or minimum values, okay. That we call it as a quantization level. See the next topic, like I'm going to discuss about the PCM decoder. What is that PCM decoder? That is pulse code modulation decoder, okay. The very important role of our PCM decoder, okay. It is going to recover or rearrange the analog signal, okay, into the digital signal, okay. It's like we have to convert, or we have to rearrange the analog signal into the digital signal, okay. We have to follow some steps. What are that steps here? Okay, we can hold our circuit, okay, whatever we have that analog circuit, okay, we have to use, and we have to hold that particular circuit. After that it is going to amplitude the value of our pulse till the next pulse it is going to arrives, okay. This is the one step, okay. Then next one, we have to pass the analog signal through the low pass and the high pass filters, okay. Here we are using low pass and high pass, okay. But in this PCM decoder, okay, we can use only the low pass filter, okay. Because like why? Because we are using the low pass filter, means for the cutoff frequency, okay. We are using the cutoff frequency, so that we are going to use the low pass filter, okay. This low pass filter, it is going to equal to the highest frequency in the pre-sampled signals. This is the second step. Then the for that is the last step. like the value of our higher zones, that is nothing but that is the highest value of our L zones, okay, is the less destroyed, or it is a very well, like it is a very like a poor destroyed signal. It is going to recover, means it is very poor signal. It is going to recover while transmitting the signal from analog to digital. See, this is the PCM decoder. The next one is like we supposed to use the PCM decoder. Okay, we have count down the five components. That is, one is PCM decoder, second one is digital data and analog data or analog signal. Then one more is amplitude. Okay, here the amplitude, okay, it contain both time and as well as the amplifiers. Okay, everything. Then our PCM decoder, okay, it is going to connect the samples from the digital data. Okay, that digital data, like it is going to divide the samples. Okay, that samples, it is going to convert it into our low pass filter. Okay, that low pass filter, okay, it is going to it is going to combine with the cutoff frequency. Okay, that cutoff frequency, it is going to made up with the high range of values. Okay, then finally that data, it is going to convert as the analog signal. Okay, this is the method we supposed to use our PCM decoder. Then what is the delta modulation now? Okay, this is the second analog to digital conversion. The first one is pulse code modulation, second one is delta modulation. Now we discuss about the delta modulation. The delta modulation here, it is a PCM like pulse code modulation is very complex technique. Okay, like to overcome that PCM technique, we supposed to use the delta modulation technique. Okay, then what is the delta modulation? The delta modulation, it is the very simplest modulation technique. Okay, it is going to find the value of the signal amplitude for the each samples. Okay, as well as our data modulation, it is going to find the change from the previous sample, okay, to the next sample. Okay, see, that's what here, see, you look at this is the delta modulation diagram. Okay, here here the value, okay, the value of our pulse, okay, it is going to take in the time the time, okay, that time, okay, that we consider as a time tn plus 1. Okay, that tn plus 1, we consider as a highest amplitude value, okay, than the rather than the our given time tn. Okay, the given time tn, okay, it is it should be a very lesser than of the tn plus 1, means here number of time we supposed to count down. Okay, how it is, see, you look at this here, they have using the staircase. See, this digital signal, we call it as a staircase marker or staircase signal. Okay, how we supposed to define this? Okay, how we supposed to use this staircase marker? See, you look at this this one diagram, I'll show how it is going to forming the staircase or this digital signal with the help of generated our binary values or digital values. So, see, if it is 0, see, it's showing low level value. Okay, if it is 0, it should be a low level. Like if it is 1, yes, the signal automatically rises up. If it is 1, yes, the signal automatically rises up. Okay, until, see, this is the until this, the signal should be rises up. Again, if it is 0, yes, it will be come down. Again, if it is 0, yes, come down. Okay, these all are the 0 values till here. Okay, till here, these all are the 0 values. Again, if it is 1, yes, obviously signal will be go up. Like that, our delta model, because why, like it is a very simple, okay, or a very simplest method, means based on the values, okay, the signal will be goes up and down. But our pulse code modulation, the given analog signal, that we have to divide it into like samples. That samples again we have to convert it into quantization. After that quantization again we have to decode, and then finally we are going to expect the digital signal. See, these are the long process, or these all are the very complex process. To overcome that, we have better use for the delta modulation process. Then here the delta modulation component, so we have to use the 5 component, like